Most of the matter in our universe is invisible, leaving physicists puzzled about its nature. This hidden realm is referred to by scientists as the dark sector, owing to its mysterious nature.
So the basic insight is pretty simple. Why should ordinary matter be the only type that's special? Why should we have the only type of matter that has interactions? We know a lot about the standard model particles. We know, first of all, the different forces, and we also know there are different types of particles. So maybe that's also true for dark matter. And it is funny, though, because every time you make a suggestion like that, every time we repeat the Copernican revolution, we find out we're not the center of the universe, our matter isn't the center of the universe, there's other structure. People are very shocked and horrified, even though each time we learn the same lesson over and over again. So it seems like by now we should have an open mind and be willing to entertain this possibility.
Moreover, some astrophysicists have also theorized the existence of dark stars, composed of dark matter, which might have existed in the early universe and could still persist today. Randall suggests that if dark stars exist, it's conceivable that dark planets have formed alongside them within the dark galaxies. Taking this notion further, she ponders whether the dark sector, governed by its unique forces, might also harbor complex chemistry and even support life. Such dark life would occupy the same space as us, but would be completely invisible to us. Before these theories emerged, another researcher, Mead Lane, an academic and author with a particular interest in UFO phenomenon research, wrote about very similar concepts in the early 50s. Quote, "If there are colors we cannot see, sound we cannot hear, and dense and solid bodies which we cannot discover by touch, it is certainly not too difficult to conceive of a world which, though possessing sounds, colors, and material objects, is yet imperceptible to us." End of quote. In his publication, he suggested that some flying saucers were not products of advanced military or extraterrestrial technology, but were instead manned by beings from a coexisting material plane composed of ether, which he referred to as Etheria. Now, he used the concept of ether, which we will revisit later, but much of the context of his claims intersects intriguingly with modern dark matter theories. For example, he believed that coexisting with our material planes is possible because matter has different levels of density. Lane suggested that the beings from Etheria could use their technology to change these densities with their ether ships, allowing them to appear in our world. He argued that counterintuitively to us perceiving our world as dense and solid, it is actually rarefied matter from the Etheria people's perspective. And what we call UFOs normally exist as much more dense matter than of our world, and hence invisible to us, but could be seen when their density is changing closer to our ordinary matter. To an Etherian, an object materializing on our plane would dematerialize on his. To us, it materializes in our field of perception and dematerialized when it returns to its etheric state. He further claimed that Etherians could become stranded on the terrestrial plane when their ether ships malfunctioned, and that various governments were aware of these incidents and had investigated them. Where is Etheria? According to Lane, Etheria is here, alongside, inside, outside of our world, occupying the same space as us, but completely invisible to us. Lane claimed that every heavenly body has its own Etheria realm, a world that surrounds them as vast meshes and represents an invisible habitable environment, and also a scaffold on which solid matter of our world exists. Furthermore, Lane argued that Etherians and their ether ships inspired much of Earth's mythology and religion. Men thought of them as gods or angels or spirits of the air or demons, embodied them in folklore and mythology, and forgot them little by little, but they were truly mortal beings, despite having a high level of technological and spiritual advancement. He reported that these revelations would be relayed through individuals with sufficiently developed psychic abilities, allowing them to project thoughts and contact these entities and communicate with them directly. He outlined that Etherians claimed that they are not spirits in any sense, but born to Etheria and die there similarly as humans in our material world. Now, if you replace ether with dark matter and Etheria with the dark sector, you'll find nearly identical intersections with modern dark matter discoveries. Lane was regarded as a fringe theorist by the scientific community. But 67 years later, modern scientists are asking the same question. What if an invisible civilization could be living right under our noses?
But let me just start by telling you about the makeup of our universe, which I thought everyone knows, but my close friend who's here said he didn't even know this till yesterday when I mentioned it. This picture is sometimes called the cosmic pie. It tells us what the energy of the universe is made of. And one thing you can notice is that very small slice, the white one, is atoms. It's the stuff that we're made of. The stuff that we're made of is only 5% of the energy of the universe. About 5 times more than that in terms of energy is something called dark matter, which I'll tell you more about. But just briefly, dark matter is matter in the sense that it acts gravitationally like ordinary matter. It clumps together into galaxies, for example. But it doesn't interact with light the way our matter does. It doesn't experience any of the standard model forces that we know of. It only experiences gravity as far as we know. So dark matter has been observed in many different ways. I'll outline a few of them. But we can't see it the way we see ordinary matter. So it's not made up of ordinary stuff. It's not made up of atoms. It really is something quite different.
Exploring the idea of how different dark matter is, this article offered an intriguing metaphor. Quote, "If an alien managed to visit our universe from a parallel reality, there is a high chance they would not even notice we exist. The aliens might not even notice all the stars and the planets that orbit them. They could even miss the vast clouds of dust that float through space. All these familiar things only make up a fraction of the matter in our universe. The rest is something else, a material that nobody on Earth has ever seen. For want of a better name, physicists call this stuff dark matter." End of quote. Astronomer Fritz Zwicky was initially seen as a fringe theorist for proposing dark matter as the primary component of the universe, but his ideas have since been vindicated. Modern astronomy acknowledges dark matter anchors everything together, similar to Lane's Etheria in the universe's structure, despite being invisible. Like the wind, dark matter is invisible, yet detectable by its effects. What's more, there is a lot of it. We quite literally don't matter. Most of the matter in the universe, about 85%, is dark matter, not the stuff we are made of. Reflecting Lane's ether meshes, galaxies form vast clusters, creating a cosmic web of intricate patterns held together by dark matter. Now, it has become almost identical to Lane's ideas that on the strands of those meshes we live. That is the so-called dense matter of our world. Modern scientists like Carolyn Crawford of the University of Cambridge now echo him, saying that dark matter is the skeleton on which ordinary matter hangs. In this study, researchers from the University of Toronto developed these ideas further, writing, quote, "It is highly plausible that dark matter is part of a more complex dark sector that includes multiple particle species and forces." End of quote. They also refer to the atomic dark matter model that postulates the existence of a dark analog of electromagnetism mediated by a massless and to us invisible dark photon. Moreover, there is a class of models in particle physics that propose a hidden sector, a mirror world that is a duplicate of our own, but interacts very weakly with it. For instance, the mirror twin Higgs theory. Such a twin world contains particles and forces that mirror those in our observable universe, including a counterpart to the Higgs boson, the God particle. Now, Lane's ideas about Etheria no longer seem esoteric and align more closely with modern scientific postulates. An invisible world of matter exists here, occupying the same space as our tangible world, yet remaining invisible to us. The parallels extend even further. Dr. Alexander Parkhomov, an experimental physicist who studied properties of relic neutrinos, wrote in his book that dark matter, including neutrinos, is diffused throughout space in systems that are held together by gravity. He suggests that objects made of dark matter are organized into structures similar to those of visible matter, such as Earth, the Sun, and galaxies. Essentially, every celestial object, including stars, planets, and cosmic dust, has a dark matter counterpart obeying the same gravitational rules. One of the mysterious objects currently under close study is mirror stars in the dark sector. Quote, "Mirror stars are, in perfect analogy to regular stars, collapsed clumps of atomic dark matter that radiate their internal energy away as invisible dark photons. These mirror stars can capture regular matter from the interstellar medium due to a tiny mixing between dark and regular photons, which quickly settles into the center, in analogy to the hypothetical capture of dark matter by the Sun." End of quote. Furthermore, on the topic of density, they noted that dark matter clumps, or nuggets, have higher density in comparison to our world planetary nebulae. They also note that atomic dark matter doesn't just interact with itself. It can also create dark atoms and lose energy. When it happens, it forms structures, much like how regular matter forms stars and planets. The fact that dark matter is more dense and has higher mass also aligns with Lane's ideas of Etheria, as a significant mass component of the universe that influences the structure of the cosmos despite being invisible. The dark sector, with its unseen majority of matter, includes mirror versions of white dwarfs, neutron stars, and even black holes. What's intriguing is the potential to develop specialized telescopes capable of observing and studying this shadow universe. The interaction between regular and atomic dark matter leads to X-ray conversion, and therefore can be directly observed in telescopes, allowing us to explore these elusive dark worlds. And it seems that at least some of the flows of dark matter were also experimentally recorded back in the 70s in the Nikolai Kozyrev's telescope. Kozyrev's astronomical observations involved a reflecting telescope and special sensors, leading to findings about signals from different directions in relation to celestial objects. His technique indicated signals from the past, from the present, and from the future, based on the object's position at various points in time. Initially, his results were met with skepticism, but now it is widely believed that the tests carried out by multiple independent research groups unambiguously confirmed the possibility of receiving such signals.
Even though dark matter doesn't emit light, you can have some other object behind that emits light, some object that does. Now, might be that the light from this object passes by some other object, like a galaxy, for example, that could contain visible matter, but it could contain dark matter. It doesn't matter, because we're just looking at its gravitational influence. And in response to that matter, the light will bend. We know that from Einstein's theory of general relativity, how to calculate how light bends in the presence of other matter. But the way that it bends will depend on the direction it took when it's going past this galaxy. In this picture, it might be deflected down, it might be deflected up. So the consequence of that is that when we see this object from here on Earth, where we're looking, we might see multiple images of the same object because we think light came to us in straight lines. So we might see either multiple images or just a spread out image, which is called gravitational lensing, which is an indication that there was matter in between this object and us. And if it cannot be accounted for by the visible light, then is clearly the presence of dark matter.
There are convincing experimental grounds that Kozyrev's technique works, and in fact can be understood as a recording of dark matter flows. Amplified by the gravitational field of the Sun, flows are coming from two directions, which shows the possibility of explaining his technique within standard scientific frameworks. Interestingly, Mead Lane's concept of Etheria encasing each celestial body also closely parallels the behavior of dark matter, which is thought to envelop galaxies and other cosmic entities. Physicist Alexander Parkhomov refers to them as shells of celestial bodies, made up of streams of dark matter circulating in various orbits. In astrophysics, dark matter is not just located within galaxies, but also forms halos around them. These dark matter halos extend far beyond the visible edges of galaxies, influencing their structure and motion. But more importantly, we now recognize a candidate for a dense, invisible realm with unique physics that influences our world yet remains unseen, aligning seamlessly with contemporary scientific principles.
So the simple idea is that it is just dark light, just like we have a proton, electron, and a photon. Maybe there's something similar in the dark matter sector. So there's a dark matter particle, a light dark matter particle, and a dark photon. And it would have, as we showed, significant consequences that give rise to observable effects. In particular, just like I explained to you that ordinary matter forms the Milky Way disk because it radiates, dark matter would do the same thing. So you could form a dark matter disk. And the interesting thing is that if dark matter is heavier than a proton, that disk would be likely to be thinner and denser than the ordinary matter disk. So there would be a thin, dense dark matter disk within the Milky Way plane, if this idea is right.
Now, from this perspective, if there is a dark chemistry, dark physics, dark light, then the idea that this dark sector is full of dark matter life is not that far-fetched at all. What we don't know for sure yet is if it is accessible or not. In that regard, Mead Lane presented another important concept of overlap of our realms. He believed that the lowest of the etheric, or dark matter as per our hypothesis states, just beyond our gases, serves as a zone of demarcation between the planes, and that there is some overlap of phenomena of the etheric and of our world of matter in this zone. One of the candidates to such a zone of demarcation are complex plasmas. Complex dust plasmas, a type of light and flexible matter, not only help us understand the hypothetical ether, but also can exist in 3 states, similar to crystals, liquids, and gases all at once. A fascinating aspect of plasma physics is how it forms stable patterns like vortices, layers, and crystal-like structures. Dust plasma is particularly interesting because it contains larger particles that, unlike what we'd expect, attract each other in the plasma, creating organized patterns. For example, they can form spirals similar to DNA, which can even exchange information. This plasma can also simultaneously display characteristics of gases, liquids, and solids, showcasing a versatility that once puzzled scientists when they studied ether. The parallels between plasma and ether extend further, with past theories of ether now effectively explaining dust plasma physics. Vadim Tsitovich, a renowned physicist and authority in dust plasma research, highlights this, referencing Georges Louis Lesage, an early gravity theorist. Tsitovich notes, attraction forces between dust particles and plasma are similar to the Lesage shadow attraction model for gravity interactions related to the screening of flows of a non-existent ether toward one of the interacting particles by another neighboring particle. Unlike the Lesage model, forgotten after the creation of the relativity theory, which has no place for ether, flows in a dust plasma are absolutely real, electron and ion flows, and their efficiency strongly depends on the characteristic size and the efficiency of the interaction of flows with particles. End of quote. Tsitovich denies the existence of fixed ether, which is incompatible with relativity theory. But dynamic concepts like Dirac's ether and the quantum vacuum offer intriguing theoretical possibilities. Tsitovich's paper contrasts 2 dusty plasma distributions. One uniform under Earth's gravity, and another uneven in space, forming vortices. Historical theories like Descartes envisioned a matter-filled universe without empty space, where vortices explain motion. Modern sky maps resemble Descartes' vortices and dusty plasma dynamics, rather than conforming to standard astrophysical models. This cellular cosmos structure points to universal self-organization processes. Zitovich suggests in his work that dust plasmas could be potential candidates for intelligent, non-organic life in space, emphasizing that self-organization occurs universally across scales, resulting in fractal, self-similar patterns. This behavior suggests the universe operates as a dissipative system, a system that continuously absorbs and expels energy, while forming complex structures from simpler components. Then it becomes apparent that the cosmos' cellular structure isn't coincidentally similar to that of a multicellular living organism or to the neural network of a human brain. Ancient Greek philosophers such as Parmenides and Zeno pioneered the concept that the cosmos, or being, constitutes a singular, indivisible living whole. And such a concept of everything being fundamentally connected, supported by some modern quantum ideas, has appeared in nearly all cultures through the centuries.
Do you copy over? Running time jump program. Opening the vortex. Start the countdown.